Now let's cover an ENIG and ENEPIG process overview. So ENIG stands for electroless nickel immersion gold. Adding the electroless palladium um, will provide the ENEPIG final finish process. Now the process goes from left to right, as you can see in the blue arrow, and it starts with a cleaner. This helps reduce surface tension on the board and also removes palladium from non-plated through holes. The Cascade DI water rinses are used throughout the process to ensure that we basically eliminate dragged-in chemistry for the purpose of avoiding cross-contamination of the other chemicals. Now, an edge bath is then used. This edge bath will help smoothen the copper, and this will remove approximately about 1 to 1.5 microns of copper thickness. Now, a hot sulfuric bath may also be implemented, as you can see on the bottom left there, especially when working with thick panels that have the through holes. This way you can flush out any remaining edge solution. And really by doing this, it helps avoid the issues of skip plating, if you haven't heard of it, which pretty much involves some of the areas of the substrate to not undergo ENIG or ENEPIG plating. Now, the sulfuric acid pre-dip is a common ion dragon. And then next you move on to a palladium-based activator, which will deposit a palladium seed layer of approximately 100 angstroms in thickness onto the panels. Now the sulfuric acid post-dip will then be used to remove any excess palladium, especially in the thicker panels that have those through holes. Now in the green there, we have the electroless nickel bath itself. It's made up of nickel metal content, reducing agent, chelators, stabilizers, and also pH regulators. And these pretty much all work together to ensure that we deposit our nickel layer onto our substrate or panels. Now on the bottom right hand side there, you see the electroless palladium that can also be implemented. And it's better for corrosion resistance as compared to ENIG, just due to the nickel being 3 times more easily displaced compared to palladium when you're going through immersion gold. And I'll be covering an explanation on nickel corrosion. I'll go over the mechanism later on in this presentation. Now, the metal deposition is finalized at the very end with the yellow there in the immersion gold, which involves a displacement reaction. Where essentially your gold layer is deposited onto the nickel surface and simultaneously displaces nickel ions in solution from the nickel surface layer. All right, now let's discuss electroless nickel. So these two products here are two of our over 20 electroless nickel products at Uyemura. The NPR4 deposits 6 to 9% by weight phosphorus. It is skip and corrosion resistant and has excellent stability and resolution. Now the NPR8 is a newer generation bath and deposits 7.5 to 10% by weight phosphorus. By having a lower stabilizer content and also depositing a higher phosphorus content compared to the NPR4, this NPR8 bath provides enhanced corrosion resistance and higher plating initiation on the substrate or panels. Now this bath also has improved tolerance to dry film resist for the selective finishes. And to finalize there, the NPR8 also has excellent stability and resolution. Now the top-down SEM image that you see with the red arrow shows the structure of the nickel surface. And the very right-hand side cross-section image